Hello everyone and welcome back to this next lecture. So in the previous lecture I talked about who would benefit from this course. In this lecture I'm going to talk about some of the requirements for completing this course. And the reason why I have this is a part hardware course, and therefore it is essential that not only you have some of the software and also this course material, but you also have to purchase some hardware kits. So in this lecture I'm going to describe how you can set up a small mini lab either in your own home, or you can set it up even if you are working in a company or university. So since this course is about microcontroller programming, it is extremely essential that you actually program a microcontroller while you watch these videos. So in these videos I will be doing live coding sessions, right? So I won't just cover the theory. There will be some theory about microcontroller architecture and which registers and how they need to be configured. But there will be live coding sessions where I will be showing how different peripherals can be used. And also I'll be showing videos where I'll be actually showing waveforms on oscilloscopes and also other visual effects such as glowing LEDs, right? So these things I will be showing in these lectures. So it'll be great if you could also have a similar setup at your home or your lab or wherever you are. So the most important, of course, is that you have to purchase a microcontroller kit. And specifically for this course, I would say you should purchase the TMS320 F28069 microcontroller kit. Now there are many microcontrollers available from Texas Instruments in the C2000 series, but this course will cover specifically the F28069, right? So you can also potentially use this as a base for other microcontrollers like the F28335. It's not very different, but still, if you can purchase the exact microcontroller, that will make it much easier to follow this course. So the good news is that even though you need a microcontroller kit, nowadays there are many low-cost versions available both from Texas Instruments as well as many other vendors. And the best part is these kits are usually in stock, so you can receive them in just a few days. So I'll talk about that soon. Now there are two options for buying the microcontroller. The first is what is called as the TMDS Dock 28069. Right? So this is an F28069 Piccolo experimenter kit. Right? And this is an image here. I'll show you the image very soon on the Texas Instruments, but it actually has two parts. So there is a control card, and this control card is the one that actually has the microcontroller chip. And then there is the docking station. So this docking station here, as you can see, this is a connector where this card actually fits in. And it comes the USB cable to connect this entire kit to your host computer. It comes with the CD, but I think the CD is pretty much a waste. You can always download the latest version from the Texas Instrument website, and I would recommend that rather than use this CD because it usually has an outdated version of Code Composer Studio. So the cost of this is approximately 200 USD, alright, $200 US. Now it's a bit on the expensive side. This option has been available for a long time. Right? For example, I've bought similar docking stations of 28335 and other microcontrollers almost 10-12 years back as well. When I was doing my postdoc, when I was working in a company, we had these kits. So it's pretty old kit. Now I'm going to go over to the Texas Instrument website and show you how you can actually look up this kit, and also I'll show you maybe on the DigiKey website. Alright, so now I'm on my Google Chrome browser. You can use anything you want. And I'm just going to Google Texas Instruments. So it takes me to the Texas Instruments website. Alright. And here I'm going to look for F28069. And here you can see the very first link is the one we want. This contains everything, including data sheets and everything else. And I'll use this many times over and over again. Right? So this is the actual chip, right? This is the chip. If you ever go to an advanced stage where you actually start creating your own control boards and you need the chip, you can actually buy this chip as well, right? So I'm going to go all the way down, and here is where the options is of how you buy it. So this is the first one, that is TMDS dock 28069. This is the one I talked about. So I'm going to open this, and this is what it looks like, right? So you can see there is a docking station, and this last one is the one which I posted, right? So the best part is all you need is this kit connected to your host computer. Code Composer Studio is freely available, and you are ready to go, right? And this is approximately 200 USD. You can even buy it from a distributor. Actually, instead of doing this, let me go to Google again, and I will show you DigiKey. Of course, depending on where you live, there may be other distributors which are much faster and also actually give you a better price. But that's a different matter. I'm going to Google here again. I'm going to search here, not Google. I'm going to search here F28069. And here you see there is the Embedded MCU DSP evaluation boards. So I'm going to click on that. And you can see the second one is the TMDS dock. So you see there are 41 in stock. Usually they do maintain stock because it's fairly popular one. And the price, of course, these prices, remember, I'm in Canada, so these prices are in Canadian dollars. That's 366 Canadian dollars. But 366 Canadian dollars is approximately 200 USD. Alright, so this is one option. I'm going to close all this, and I'm going to go over back to my presentation. So I'm back in the presentation. I'll go over to the next slide. And this is option 2. For getting the same TMS320 F28069 microcontroller, this is called as the Launch XL F28069M module. It is a development kit with exactly the same microcontroller and all other features exactly the same way, right? So it is a single card. There is no separate docking station and control card. It is a single card. It has a microcontroller chip, and it has a USB connection, right? And this kit also comes with a USB cable. So you don't have to buy a cable. It comes with a USB cable, and the cost of this is just around USD 40, that is $40 US. So as you can see, it's drastically less than the previous one. The only thing is this is more of a development kit, whereas that was more of a general experimenter kit. So this is more if you actually want to expand your control code, control cards, and use this, right? On just after, I have both of them, and I'll be showing you videos with both of these. But just in case you wanted to know, this is a little more difficult to use as compared to this experimenter kit, right? Especially when it comes to accessing the pins and also the number of pins which are made available. But again, for this course, both of these can be used with the same amount of ease, and you can follow every example using either of these, right? So quite obviously, if you're building your own lab, home lab, it is much better to have this because it's 1/5 the price of the other one, right? This is just $40. The other one is $200. So I'll go over to the Texas Instruments website, and I will show you that card. Now I'm back on the Texas Instruments website, and this is exactly where we were at the TMS320 F28069 page. And we had actually checked out this option, that is TMDS dock 28069. Now the very first option is the one we are looking at, and as you can see, it is around $39 US. So I'm going to click on this, and this is how it comes. And you can see it comes with. It's pretty much a complete evaluation board as well, right? So for example, it also comes with a USB cable. It doesn't come with a CD, but as I said, the CD is pretty much useless. Even if you buy the other option, that is the experimenter kit, I would not recommend you to use the CD. I would just recommend you to download all software and all files from the Texas Instruments website. So this too can be bought from DigiKey. I'm going to go over and open DigiKey, and I'll just enter the same part all over again. And here again, and the very first link is that, right? So as you can see, they actually maintain more stock, and again the price is in Canadian dollars, 68 Canadian dollars, but that comes to around 40 USD, right? So this is what it is. So again, both of these kits will do perfectly well in this course, right? You can choose either of them. It's not that the more expensive one is better or is the preferred one. It is just that the more expensive one is a more general experimenter kit, whereas this is more for launching your designs, right? That's the only difference. So I'm going to go back to my presentation. So now I'm back in my presentation, and this is how you get the experimenter kit. You have option 1 or option 2, right? In this course, I'll be using both. So whichever you choose, no problem. I will show you exactly how to use it. You'll be able to follow all exercises with both options. So you don't have to worry about which you want to choose. If you are building a home lab, go ahead and buy this cheaper one. No problem. You'll be able to complete the course with it. Now, I would strongly recommend that you buy a cheap oscilloscope. And the reason is that a large amount of the examples in this course will be related to pulse width modulation. And we are dealing with high frequency signals in kilohertz of frequencies, and those you cannot do those experiments with flashing LEDs, right? For example, if it's only a couple of hertz or a few hertz, the frequencies that we are generating, we could actually just flash LEDs. But those are not possible with pulse width modulation, right? Because to make this course practical and actually applicable in power electronics, it is essential that I generate some practical pulse width modulation examples. And for that reason, I would say go ahead and buy a cheap oscilloscope. So I have this specific oscilloscope with me. All right. So this is something I bought from Amazon. And my suggestion is, whatever oscilloscope you buy, please buy one with at least 2 channels. And the reason is that we need 2 channels for comparing waveforms. If you have a single channel, you can observe one waveform, but you can't compare it with anything else. So if you have 4 or 6 channels, by all means go ahead. Like for example, if you are already studying at a company, you're studying at a university or at a company, and you have good lab facilities, go ahead and use good oscilloscopes. You don't have to buy this. This is an option for those who are building a home lab, who are doing this personally on their own and on their own time, right? This one costs around $50 USD. I bought it from Amazon, and I'll show you that link very soon. Whichever oscilloscope you choose to buy, please buy one with at least 10 megahertz bandwidth. All right. The reason is that we will be generating frequencies, PWM frequencies, up to around 10 megahertz, around 10 kilohertz. Sorry, we'll be generating around 10 kilohertz because we are talking about general switching frequencies for power converters, right? And look for something which is around 50 megasamples per second, right? In terms of its own sampling frequency, because otherwise you will end up with very granular waveforms which don't really look good, nor do they actually give you an understanding of how things work, right? So look for at least 2 channels, look for something with at least 10 megahertz bandwidth and at least 50 megasamples per second, right? Now, this one has a signal generator, but you do not need a signal generator, right? In this course, I will not be using a signal generator or a DC power supply or anything else. The signals will be generated using the microcontroller itself, right? For those examples where you need a different kind of waveform, I will be showing you how you can actually create those waveforms using your microcontroller, right? So you do not need a signal generator. So do not, if you have an oscilloscope with a signal generator, by all means use it. But I would say do not bother with signal generation when you are looking for an oscilloscope. You just need 2 channels, 10 megahertz bandwidth and 50 megasamples per second. Now I'll go over to the Amazon website and I'll just show you how to look for some oscilloscopes. So I'm back on my Chrome browser and I'm just going to type Amazon. Alright, finally decided I was not a robot. So anyway, let me come and look for low cost oscilloscopes. Alright, and here you will get some low cost oscilloscopes. Now you can actually decrease this cost. I'm going to decrease it all the way up to around 100 because this is Canadian dollars, so therefore that's good enough. And let me click on Glow. So you see some of these will show up, and these are all prices listed in Canadian dollars. Check it out. What's important is, as I said, you must look for something which is at least two channels per second, So something like this won't do, right? Because clearly it has one single channel, right? And let's come all the way down here. Yeah, this one will do because it has two channels, and this is actually the one which I have. Again, I'm not endorsing anything. All I'm saying is, whatever you choose, look into them and look for something which is at least two channels. Unfortunately, I do not see a way to actually narrow down your search, but you would have to look through and just look for something with two channels and the other specifications which I told you, right? There are a few, and at different, like for example, this is probably more than even that. But anyway, as I said, more channels are always welcome, but do not buy one with only a single channel. That won't work. Like something like this with a single channel will not work because you cannot compare signals. And later when we actually work with pulse width modulation and we are looking at phase shift control, then you will not be able to observe the phase difference between waveforms. Now I'm going to go back to my presentation. So I'm back in my presentation, and besides the oscilloscope, we also need a few more components. So for example, I would recommend that you buy maybe one or two solderless breadboards, and I'll go over and show them as well. This is very good for connecting auxiliary circuits, right? So for example, I will be showing you how you can connect LEDs to your GPIO pins. You can flash the LEDs, you can turn them on, turn them off, and these are quite useful even in power electronic applications because you can use these pins to control, number one, LEDs for display, like you want to show to the user that there is an overcurrent error, overcurrent fault, or an undervoltage fault, or sometimes even you want to use it for control, like you want to use it to turn off a relay, which in turn controls a contactor. Right? So you want to disconnect your converter from the grid. Then you can use these GPIOs for that purpose. And this way, using these breadboards, we will play around with some small circuits. So the cost of these solderless breadboards is around $5, right? Around about. Now, you should buy a small roll of wire, and I would recommend around 22 AWG. This is necessary for small connections, making connections on your breadboard, making connections from your microcontroller kit and other places, things like that. Again, a small roll of wire is probably around $5. Again, you will need a wire stripper or cutter because quite obviously you do need to strip these wires, you need to cut them and things like that. So please, you will need a wire stripper or cutter. Now, I will use a few resistors in this course. The most common, I will use only one resistor, and this is a 2 kilo ohm 0.25 watt or quarter watt 1% resistor, right? You can buy just a few of these. I would say buy around 4 or 5 of these, or if you want, I will show you very soon on Amazon, you can buy a small box for just around US $10. So this small box will have a resistor collection from like 1 ohm all the way up to 1 mega ohm, and maybe each value is around, you have around 10 of each, right? So that's pretty good to start a home lab. Now, you will also need 2 electrolytic capacitors, right? This is when I am describing how to use the analog to digital converter, we will be converting a digital signal to a kind of an analog signal. We'll be creating a sawtooth waveform, and we'll be feeding that sawtooth waveform to the analog channel, right? So for that, we need 2 electrolytic capacitors, 10 microfarad and 22 microfarad, right? So you can buy only these if you want. 2 kilo ohm resistor and 10 microfarad and 22 microfarad electrolytic capacitors. And the voltage rating should be around 25 volts because after all, we are working with a microcontroller with max 5 volts, right? So anything more than 5 volts will do. If it can even buy like 12 volts or 15 volts, no problem. You can, however, also buy a small box of electrolytic capacitors for around $10. And I'll show you that on Amazon as well. This is if you want to set up a small home lab and you want to play around with electronic circuits, such a box can be useful. Again, they have electrolytic capacitors from 0.1 microfarad all the way up to 1000 microfarad. Now, you will need a few jumper cables, and these jumper cables are necessary for making connections from your microcontroller kit to the breadboard. Alright, because the reason is that these connections are actually meant, you are supposed to actually connect a female connector below this and mount this on another PCB, right? They aren't actually supposed to be used for connecting here, but we are going to do that. But the problem is these pins are really close to each other, and there's a very real possibility that if you try to use a crocodile clip or something else, you might actually cause a short circuit. So it's better to have a jumper cable, and I should be showing that very soon. And again, you need around 5 of 10 of these. I would say around 5, 6 of these will also do. But you can buy a small bunch, a small box for around $5. So now I'll go over again to Amazon and show you where you can buy these. So I'm back on my Amazon website. I'm going to go up, and now I'm going to search for all those things which I said. So the very first thing is solderless breadboards. Yeah, so this is the second one. And as you can see, there are many options. You can buy a pack of 3, you can buy whichever you want, however you want. As you can see, the price is around, these are all Canadian dollars, so it's going to be even less in US dollars, right? So these are solderless breadboards. Now, I will show you a wire stripper. You can buy any different type of wire stripper. Again, many of these are actually will be both stripper and cutter, and I have one of these. I have something similar to this. So these are quite convenient because you can, main thing is just make sure you can strip a 22 AWG wire, right? That's all that you need to make sure, because some of these have different ranges. They only use some are used only for very fine wires, some are used for very large wires. So just make sure that you know what it is. And I will just say wire 22 AWG. So this, you can buy any one of these, like for example, just one of these will do, or you can buy black and white. You can buy a whole box. You can see there are different prices, again Canadian dollars. So just check it out, right? Whichever you want. The cheapest is, for this you just need a few connections to be made, so you don't need a great amount. If there is an electronic store close to you, you can just go buy a small bundle as well. That will be just as fine, right? Now I'm going to go to resistors. So again, as I said, you can buy a small box, right? The main thing is try to buy 1% resistors. Don't buy 5% resistors, right? Because 1% resistors means the error, the tolerable error is just 1%, and that's usually better, especially when you start using small values, resistors of low value. 5% can actually be a fairly large error, right? So choose 1% resistors. You can choose any of these. Like for example, this is an entire assorted kit from 1 ohm all the way up to 3 mega ohm, right? But look at the prices. These are all Canadian dollars. This in US dollars is around 10, right? We need only one, which is around 2 kilo ohm. Even if you use 2.2, that's also okay. If you have, again, if there's an electronic store close to you, just walk over and buy just a few resistors. That will also do. So now that resistors is done, I'll talk about capacitors. And again, here you can see this, you can buy a box, right? So there are different prices. It's an assorted box from small all the way to big. I bought one of these because I'll be doing several such experiments in the future. Again, you need only 2. If you really want to cut your cost, you can buy only a 22 microfarad capacitor and a 10 microfarad capacitor. But if you want to set up a home lab, you can buy any one of these. Right? So with this, I think we've covered pretty much everything. I will go back to my presentation. Actually, I forgot one thing, which is a jumper cable. So let me show you that before I go back. So jumper cables. No, these aren't what I want. Just look for jumper cables for electronics, because quite often you end up with car jumper cables. You don't want those. So for example, if you check these out, these should be good. Make sure that you have male to female. That is, on one end you have a male This is necessary for connection to your solderless breadboard, and the other side you have a female which you can connect on your microcontroller pins, right? So this one is an assorted box. So it has like female to female, which you can use for connecting between microcontroller pins. You have male to male. I guess this is if you want to connect between breadboards, and you have a male to female, right? So something like this would be just as fine, right? So this is for 10 Canadian dollars, right? So I think with this we've covered most of the small components we need, and now I can go back to my presentation. So back in my presentation, this is the list of components that you should buy for this course. Again, they all, unfortunately, when you're doing hardware, you do need to buy some components. So let me just summarize what we need in the next lecture. So as I said, unfortunately, since this is a mini hardware course, you will need to make some additional purchases besides this course, right? The only thing is I've tried to keep the cost as low as possible, and I am also using many of these low cost components because I would like to ensure that whatever is done in this course can be followed by somebody who is also using the cheapest components that are available online, right? So to sum up, if you are using the Launch XL F28069, then the total cost is around $40 plus $40 for the kit, $65 for the oscilloscope. So these are the two main components. And then you need another $50 for all the other assorted components. And the result is maybe around 150 USD. If you have if you go for the TMDS dock option, then of course the option is $200 for the kit, $65 for the oscilloscope, and then another $50 for the additional components. That's around 310 USD, right? So you have these two options. Of course, if this is your own personal project, then of course option 1 is the way to go. You only need to spend 150 USD. I do understand that in some parts of the world, 150 USD is quite a lot of money. In that case, I would suggest that maybe a few students pool your resources, maybe 3 or 4 of you can buy these components, share the cost, then maybe it just comes down to around $30-40, and that is affordable for many people, right? So you can think of something like this. So with some of these basic components, you have a function in MiniLab with which to complete this course. And as I said, of course, if you're learning independently or you want to just have your own lab that you can continue further, you can start with option 1, right? That's always the best. Cheapest is always the best. You can upgrade as and how you feel your interest goes on, right? If you are interested, you like what you do, maybe you can upgrade later, not a problem. And of course, if you're already working in a university or you're working in a company and you have good lab facilities, then you don't have to worry about all these things. You just have to buy the microcontroller, right? And if you also have the microcontroller, then fantastic. Then you don't have to do anything. This course is all you need, right? So with this, I hope it is very clear how you can set up a basic electronic lab. And now that we are done with the basic electronic components, the other requirement is that in this course, we will be using C programming, right? So C programming is essential for this course. Every example will be with C programming. You don't have to be an expert, right? But a basic knowledge of variable types like what are int, float, double, how do you declare variables, how do you declare functions, how do you have loops, conditionals, these basic things are what you need. That's all. In this course, I will describe some of the advanced features of C programming with respect to microcontrollers such as structures, interrupt service routines and others. So those which are required specifically for microcontroller programming, I will cover in this course. So you don't have to worry about how an interrupt is or how specific registers will be done. Those are things which will be covered in this course. You don't have to read about that. Only know about basic programming. Things like, just do maybe a few examples like, looping through an array or sorting an array, things like that, right? That will just give you some quick practice. So you can find quick course on C programming on many online websites. Just Google C programming tutorial and probably 100 will come up. So you can choose any of them, right? Again, no need to be an expert, but before you start, just gain some basic knowledge so that it doesn't all look completely alien to you. Now, last is you need a computer with either Windows 10 or Windows 11, right? I am using a computer with Windows 11. but I believe Windows 10 should also be okay. Windows 10 is going to be supported until I think October 2025. I don't know the exact date. So if you're using any time before that, I think you should be able to follow along, should not be a problem. Now we will be using Code Composer Studio, and I'll be using also downloading some additional software for the examples that Texas Instruments provides. And all this will need around 10 to 15 GB of hard disk space, right? So make sure that your computer has around at least this amount of hard disk space, right? So this is all we need. So this is a list of requirements, that is hardware requirements, software requirements, computer requirements, and this is what we need. This is what I'll be doing in this course. And as we go on, we will be building small circuits, we'll be programming microcontroller, and I hope that we don't need anything else, right? So if you have any doubts about what I talked about, or if anything is not clear, again, I only showed Texas Instruments, DigiKey, and Amazon because I'm in Canada and these are what are typically used. Depends on where you live. There may be other marketplace sellers who are much more efficient, much cheaper, and much faster. By all means, look for them, right? None of the things which I showed are what I recommend. These are just things which will work, right? So go ahead, use your imagination, and feel free to cut costs. Walk over to an electronics store, maybe even talk to the people there and say, I'm doing something like this. What do you recommend, right? So try out all these options. If you have any doubts, please do post in the Q&A forum and I'll be happy to help you out. Otherwise, I will see you in the next lecture where I'll give you some tips on how best to complete this course. Thank you so much for listening, and goodbye for now.